Okay, in this video, we're going to take a look at changing our organic molecules just a little bit. Up to this point, we have been looking at molecules that only contain carbon and hydrogen. So we've done things like alkenes, where we have a double bond, and alkynes, where we have a triple bond. In addition to carbon and hydrogen, organic molecules often contain the atom oxygen as well. And it can be added into the molecule in several different ways. So we're going to spend some of our time looking at these remaining 6 types of molecules. They are called alcohols, aldehydes, ketones, carboxylic acids, ester, and ethers. And each of them have oxygen in the molecule, but added into the molecule in different ways. And that's going to affect how the molecule behaves, and it's going to affect some of its physical properties. So we've already been talking about whether things melt easily or whether they're soluble in water. By adding on O's in different forms to these molecules, we change the way that those molecules react with the environment or their physical properties. Now, we're only looking at 6 of them. This is a list of all the common functional groups that you may come across if you continue studying organic chemistry. So we've done these 3 here. Those are the alkenes, alkanes, and alkynes. And then I picked off 6 more, the aldehyde, ketone, carboxylic acid, and then a couple more in here. So we're just starting to scratch the surface of what is actually possible with organic chemistry, but it'll give us a good idea of how the program works and how you can name things and predict their properties. Okay, so for instance, let's just take a look at this molecule. These 2 molecules, if you look at them, they have 1, 2, 3, 4 carbons. This one also has 4 carbons. So they're both based on a 4-carbon chain, which would be named as bute. Now, where these are all, the carbons all have H's on them, that just becomes butane. Butane. But because there's this OH here, and we're going to learn this naming in the next video, this thing is called butan 2-ol. And the OL tells the reader that there's this extra oxygen on the butane molecule. And just looking at its properties, I pulled up and looked up their boiling points. Butane, which is a gas at room temperature, it has a boiling point at -1, it'll start to boil. Just by adding this extra O, we change that boiling point to 98 degrees Celsius, almost as high as the boiling point of water. So changing one little atom in a molecule can make a big difference in its properties. And we're going to just look at starting to understand how we can predict what those changes will do to a molecule. Now, adding oxygen to a hydrocarbon, as we've already discussed, hydrocarbons are non-polar, meaning they don't tend to mix with water. Remember, water is polar, H2O. It has that oxygen in it that makes it a very polar molecule. And hydrocarbons, which are just chains of C's and H's, those are very non-polar molecules, so they don't mix. So when we add oxygen to a hydrocarbon chain, one of the things we're going to do is we're going to make that molecule, whatever it was, more polar. So if we look at our example from the last slide, butanol is more polar than butane. Butane is very much a non-polar molecule. Now, when things become polar, they can then attach themselves to other things that are polar. So that's why we've talked about things like water. So if we draw a water molecule that has an oxygen in the center, it has 2 hydrogens that are on it. And we've drawn the fact that the oxygen is a little bit negative and the hydrogens are a little bit positive. So it can be attracted to other water molecules. But if we put a molecule in like that butanol that we were just drawing in the previous slide, it also has carbons and hydrogens, which can't attract to these positives or negatives, but on the one end, it had an O and an H. And that means that that end of the molecule This O is a little bit negative, just like it is in water, and a little bit positive at the hydrogen end, just like it is in water. And so then attractions can be made between the water molecules and the alcohol molecules. And those attractions allow the alcohol and the water to mix. If this little OH group wasn't there, there would be no attraction for the molecule to the water, and the two things would mix. Now, if you remember, we talked a little bit about why this happens. Oxygen atoms have a very strong pull on electrons. So when we look at a bond, like up here where we have the, just draw part of it, where we have the O and the H, we remember that the electrons in that bond are pulled toward the oxygen more than they are toward the hydrogen. So putting oxygen in a molecule anywhere causes the electrons to get pulled toward the oxygen, and then that end of the molecule becomes negative, and the other end of the molecule is positive. So that difference in the oxygen's ability to pull on electrons is what makes things polar when we add oxygen to molecules. Now, when a molecule becomes more polar, or we can think more like water, because water is really one of the most polar things we can think of. When a molecule becomes more polar, this is what happens. Number one, you increase its solubility in water. Well, we've used that term before. We said like dissolves like. So if you're more and more like water, then you're going to dissolve better and better in water. So the more oxygens we add to a molecule, the more soluble it should become. Now, melting point and boiling point, if you recall, we talked about this once before. In melting point, we have to take the solid and separate the particles of the solid to turn it into a liquid, which those particles are a little bit further apart. And then for boiling point, we have to turn the liquid into a gas by very much separating the particles. Okay? So the boiling point, or what temperature these things happen at, because remember, boiling point and melting point are temperatures. The temperature at which these things happen are determined by how hard can these two molecules hold on to each other. So in ethane, because it doesn't have any polarity, it doesn't have any oxygens in it, two ethane molecules really cannot hold on to each other very strongly. It's very, very weak that they can hold on to each other. And we called that back in another video, the London dispersion forces. But these are extremely weak and easily broken. So it's very easy to turn ethane from a solid to a liquid, to a gas. Now, the ethanol, which is the same molecule except it has an O on it, it's got a spot where there are negatives and positives. So this negative and positive on that ethanol molecule can line up with the negative and positive on another ethanol molecule. And because those are charges, we get a fairly strong attraction between these two atoms. It takes lots of energy to separate the atoms of a solid ethanol, so frozen ethanol, into liquid ethanol and into gaseous ethanol. So the better the polarity, the better the attractions between two molecules, and the changes that we will see in their melting point and in their boiling point. So oxygen is going to come up in the next few videos as we talk about the other types of molecules in several different ways. And I'm just giving you a brief list here of the different ways you're going to see them. I'm going to do a little graph here from most non-polar to most polar, because those are the opposites of each other. And of course, the most non-polar are your alkanes. So you could put alkenes and alkynes here as well. They are completely non-polar. So they don't dissolve in water, and they don't have very good high melting points or boiling points because they can't hold on to each other very well. The first way we can add oxygen to a molecule is something called a carbonyl group, and that's when you see a C that has a double bonded O attached to it. And those show up in molecules that we're going to learn about called aldehydes, and ketones. So we'll take a look at those molecules and learn how to name them. But they're a little bit polar. They're not quite the most polar thing, but they're a little bit polar. The next one is adding an O and an H, and that happens in molecules called alcohols. And they are quite a bit polar. They will dissolve fairly well in water and have some significant melting points and boiling points. And then finally is this group called a carboxyl group, and it shows up in things called carboxylic acids. So in carboxylic acids, you would see this little group of atoms, and that makes them very polar. This is probably the most polar group that we're going to look at in all the things that we're learning how to name. So if you can remember that kind of chart, then when I ask you if a molecule is polar or not, you have some idea of where it fits on this chart. And you can decide, is one molecule more polar than the other molecule? And if it is, we can start to make predictions about solubility, boiling point, and melting point. And I think we'll just leave it right there at this point. That's long enough video for this time. And then we'll do another check-in a little later on about the first kind of molecule we're going to look at, which contains an oxygen atom, which is these alcohols. But for now, you're just trying to look at molecules in a slightly different way, trying to judge them as being polar or nonpolar, and start to think about what effect that would have on those three properties. Can I dissolve in water? How high is my melting point? How high is my boiling point? Okay, thanks.